Students, this is the second video regarding the chemical energetics. So let's start from here. Hess law. The law of conservation of energy states that energy cannot be created or destroyed. This is also called the first law of thermodynamics. Hess law states that the total enthalpy change in a chemical reaction is independent of the route by which the chemical reaction takes place, as long as the initial and the final conditions are the same. The states of the reactants and products must also be the same, whichever route is followed. You can see here A plus B can directly convert into C, or it can be converted first into F plus G and then C, or it can be converted into X, Y plus Z and then C. So these are the various ways. Uh, Here you can see that this is a direct route, delta H2 equal to delta H1 plus delta HR, or this is indirect route in which elements first reactant convert into reactants and then into products. Enthalpy change of reaction from enthalpy change of formation. So you can see the direct route or the indirect route. So HR, delta HR equal to delta H2 minus delta H1. To calculate the enthalpy change of reaction using this type of enthalpy cycle, we use the following procedure. Write the basic equation at the top, draw a cycle with elements at the bottom, draw in all arrows, make sure they go in the correct directions. Apply Hess law, taking into account the number of the moles of each reactant and product. If there are 3 moles of the product, like 3CO2, we must multiply the enthalpy change of formation by 3. Also remember that standard enthalpy change of formation of an element is the standard state is 0. Here are few questions. Calculate the standard enthalpy change for the reaction in this one, and for this one the cycle is here, and the relevant enthalpy change of formation are also given. Calculate the standard enthalpy change of formation of ethane, which is this one, and all the values are given here, and this is a cycle. Better to try this one yourself. I will upload a separate video in which these questions will be solved, but just stop the video here and try to solve them yourself so you can do a better practice. One of the question I solved here for you, write the enthalpy role cycle to calculate delta HR, or these are the values. So first of all, I make the equation, the same equation here. Then I make the Hess law. According to the Hess law, is aluminium, is iron, is 1.502, and this is a direct conversion, and this is indirect conversion. Delta H means delta HR plus delta H2, delta HR equals delta H2 minus delta H1. I put down the values, I got the answer minus 85.5 kilojoule per mole. So basically I solved this question for you to for your understanding. This is a question number 8. Enthalpy change of formation, enthalpy change of combustion. So basically you can see here elements plus oxygen convert into compound form plus oxygen, and these two either directly or indirectly convert into the combustion product. So delta HF equal to delta H1 minus delta H2. Basically this is a direct route and this is an indirect route. So to calculate enthalpy change of formation using the type of cycle, write the equation for enthalpy change of formation at the top, add oxygen on both sides of the equation to balance the combustion reaction, draw the cycle with the combustion products at the bottom, drawing the in all arrows, making sure they go in two directions. Apply Hess law, taking into account the number of moles of each reactant and product. Again, question number 9. I just make this first cycle for your understanding for question number 9. For question number 10, you need to do it yourself. I will, as I already told you, that I will upload another video in which I solve this question. But here I gave a hint for this one. Bond energies and enthalpy changes. So bond breaking and bond making. The chemical reaction, the energy need to break the bond is less than the energy released when new bonds are formed. The reaction will release energy and is exothermic, and the energy need to break the bonds is more than the energy released when the bonds are formed. The reaction will absorb energy and is endothermic. Bond energy. So the amount of energy needed to break a specific covalent bond is called a bond energy. We sometimes call this exact bond energy or bond enthalpy. You can see in this one reaction pathway, these are the various bonds which are shown here, and these bonds are break like this: C separate, 4H, 4O, and then here they absorb the bond energy, and when they convert into a product, they actually release the energy. So same thing for this one. So the bond energy for double and triple bonds refer to the mole of the double or triple bonds. For example of the equation related to bond energies are Br2. So here it is 193. O, it is 498. So this is plus 498. But when to O, we had to make O2. This is minus 498. It means that it is releasing the energy at this point. Every bound energy in standard enthalpy atomization is the enthalpy change when 1 mole of gaseous atom is formed from its element under standard condition. So delta H atomization H2 relates to the equation half H2 H2. The every bound energy of the CH in the methane can be found using the enthalpy change atomization of carbon hydrogen and the enthalpy change of combustion and the formation of methane. Here there is a question given, and with this formula and this cycle, it is you can calculate yourself delta H plus delta H equal to delta H atomization or delta H delta H atomization minus delta H. By putting the value we got 415.8 kilojoule per mole. It have to be divided with 4 because there are 4 CH bonds. Right. Calculating enthalpy change using bond energy. Now here I am using the bond energies NN945, HH436 and H391, and you can see here bond broken 2253, bond form 2346. So in this way there is a net delta HR. It means that delta H of reaction the basic bond energy which is minus 93. It means this is the amount of energy which is released when water and when ammonia is formed. Right. These are another questions. Question number 12. 12 part C. The answer is given here. And for the other one, 12 part A, this is the equation. 12 part B, I have just put on the values for your easiness, or you can solve them yourself. So at the end, we got delta is equal to minus 1324. This is a question from a paper. So you can see here, basically this is a very different question because they are asking about the nitric acid by industry by oxidation of ammonia. There are equation for the process shown here. The process happens in three stages, so we need to calculate the answer. In the first one, it needs to be divided with 4 as it is for the 4 moles, right? So 2 to 6. In the second one, this one, it is for the 2 moles, 4 divided by 2 minus 57. In the third one, again for the 4 moles, so minus 348 over 4, and then we add them all of them. Minus 2 to 6, minus 57, minus 87, we got minus 370. And that's it, that's all for today, and few questions may be left. I will try to make another video to solve those questions. See you next time in the next video. Thank you very much. Allah Hafiz.